All right. So to quickly go through, in the last session, we particularly saw how do you do a stash, which is nothing but taking a backup and at the same time undoing the changes to its original content. So that's what we saw in the stash. And we also saw how do we reset. That is, before you have going to do a commit, if you feel you want to undo a change, we will be doing an undo from not one area, but correspondingly, we know that we have 3 areas, right? So based on that, we used to do the undo. So that is one from your repository, and then you will have from your staging area. And if you want to do it on all the 3, that is on your repository, staging area, as well as your working directory, then based on that, we used to use option. Now, to continue, let's take a scenario where you have not just did the changes you put into the staging area, but let's say you actually did the commit. Okay, now I was telling you that until you do the change, there will be a temporary ID that has been created, and when you do a commit, it will be actually creating a commit, right? Now, what will happen? Let's say you have done the commit and then you want to undo it. Getting the problem? That you have done the commit, okay, but then you want to undo it. So what are the common scenarios that you will be doing? So these are a very common scenarios that we will be going through when we are performing a build or when we are trying to give these changes to the QA. So let's say now at a particular point of time, if you have 10 developers, all the changes given by 10 developers will be put to the central repository, right? So individually, let's say Vinay, you do the changes from your workspace, and then Syed does his changes from his workspace, and then Karnakar, Hari, each one of us does changes in our individual workspace, and then we'll all going to be pushing into the central repository. Yeah, that is the ideal scenario where each one of us will do the changes and will be pushing it individually. But now, when we have to give it to QA, what we will do is at some point of time, we will try to take the latest change from the central repository and we try to create a build out of it and then give it to the QA, so that we will be having all the changes done by 5 of us. As I said, when we have many people and all of us have submitted our change, and now when we have to give that to the QA, what will happen is we are going to accumulate all the changes, and some point of time we will be trying to create a clone from a workspace, or we will update a particular workspace so that whatever changes we have in the central repository, which has been submitted by all 5 of us, will be taken together, and from that we will be trying to create a product. Okay, so this is how every time when we want to give a product to QA for testing, we will accumulate all the changes. Then from that we create one build, or we actually create a product out of it. That is what we call it as build. And then from that we will be giving the created product or the deliverable to the QA to test. Now what happens is either while testing they might find an issue, or while you're trying to create a product, you might face an issue. So that step is what we call it as build. So we'll talk more about what is build in the next session or in the next topic. But the point here is when you're trying to create a product or build a product with all the changes that you have put into the central repository, and then at that point of time, if something is failing, now we need to find out what exactly is causing the problem, and in that, whose change is causing the problem. Okay, so let's say out of 5 of us, now let's say the change that I did is causing some problem because the change what I have done is not compatible with any one of your changes, because of which either the build or the product is not getting created, or while testing the QA might find some error. So that case, now what we can do is instead of waiting until I give a fix or whoever is the developer who has caused the problem, because until you keep that code which has bug in it, none of the other code will be working fine because everything will be failing on top of the same thing. So that is when the first point what we have to do is we have to undo that particular commit which we have already done. Okay, so this is the practical scenario where every time when a build is being done and we give it to the QA as a product, if something goes wrong, we need to find out if it is a code issue, whose code is causing a issue, and then we will try to undo that change. So that way, if you have a scenario where you have a group of changes which has already been committed, and if you're interested to undo a particular change which has been committed already, then we will be using a command called git revert. Okay, so understand this. Git revert is all about undoing a commit which has been already done. Okay, be clear in it. Is it clear, or any questions on it? Any questions on it? Or I can talk deeper onto what is the scenario.
Undoing in the sense, I have committed three IDs, I mean three commits. It will undoing entire commits or only specific whatever we are mentioned, those changes it will revert back.
Anything. That's what I'm saying. If you feel the problem that you have caused is one commit ID, or it could be three commit IDs. But ideally, if you see, you will not be considering three commit IDs. But whatever changes that you are doing will be top of the other one, right? So you have to find out the exact one and pick it out. Maybe if you have done two separate commit IDs and both of them are different and both of them are causing problems, then you have to undo both. But the scenario is finding out a particular commit ID, and if you say that this commit ID is causing problem, then we will be using a command called revert. Okay, so that it could be a single or it could be multiple commit IDs.
Okay. Yeah.
Getting it?
But here, yeah, here Vinay is asking to how to undo in central repository changes. He is asking.
I still didn't go to that. I'm just trying to give you a scenario on when is that you will be requiring to
Okay.
the change.
Okay.
Others, is it clear? Okay, so that way, now as the question comes, okay, so who is going to do the undo? So that is one question where now we can ask the respective user who has done the changes to undo, or we can do it ourselves, wherein we, being a DevOps engineer, we are also responsible for the health of the code line too. So now whatever workspace that we are using, in which we would have taken all the latest commit ID, and from that we are doing the build, right? So from that we can go ahead and undo that particular commit ID. So for that, first thing that we have to do is we have to use the git revert and the specific commit ID. If you say, it will be trying to undo that change. Okay. Now, once again, when you are trying to undo a change, practically it is not possible in Git, unlike other tools. It is because when you say a commit ID, it is a 40 characters that is set, right? Where that 40 characters is not just a random characters that it is creating, but it is actually called as a checksum value, which is nothing but it is equivalent to some data that is available in the repository. So that is how any commit that you have created cannot be changed, because Git is so powerful in security, it keeps a track of everything. But what we can do is we cannot delete the commit ID or do the changes, but on top of that, we can do one more commit. So that is when internally, if you do a revert of a commit, what it is going to do is, for a user, he might think that it is trying to remove the contents from a file which you have done a commit, and that is what you are trying to do a revert. But Practically, it will be removing the content, but along with it, it will be trying to create as if you are doing a new commit. Okay, so be clear, undoing or reverting a commit itself means you are trying to undo the content of that commit, and for that change, you are going to create one more commit. Okay, so that is how revert is going to work. So from a user, the content of the file will be reverted, that is undo. But from the Git, it is not just going to leave it like that, but whatever changes that you have done, it is going to create a commit ID once again for that also, because it is going to track saying that this is the commit you did. After that, you have to, or if your interest was to tell to the Git to revert it, then you are going to undo the content from the file, but at the same time, it is going to create a new commit ID as a reference, and it will keep it. So that is how, from an administrator's perspective, we will be having the commit ID as a track on why did you undo it. You will have the details, and at the same time, from a user's perspective, if you look, the content of the file will be pointing to the previous content that he had before the commit. Okay, so that's how we'll be solving both the requirements. Now, before getting into the deep of that concept, let me first show you how do we revert it. Okay, so first, let's see whether we have any changes. Okay, we do not have any changes. And let's quickly see some latest 3 commit IDs that we have. So what I'm going to do now is, I will try to do some change in one particular file, and I'll create a commit, and then we will try to undo that commit, that is completely revert that commit, and see how Git is going to behave. Okay, now we did some change, and this is the commit ID that we have. Okay, and let's choose a file. Okay, let's choose 5. So in the file.java, we have a line called idea1. So in this, let me quickly add a dummy line. Okay, so for this, let's do a git add, and now let's do a git commit. So now what would have happened for this? Pretty much we would have created a new commit ID. Okay, so for our understanding, let me not make it complicated. So let's try to do a revert of this itself. So let it first show what is the commit ID it has created. So now if you see, it has created a new commit ID. Okay, so now to understand, first we had this commit ID, right? Let me put it up this way. Okay, so we had this commit ID. At this point of time, what was the content of the file.java? So we had only one line, correct? So this was the content of the file.java. Now, what we did is, on top of this, we created one more commit, okay? And that commit is nothing but this one. And for this commit, what actually happened was, we added some content to the file. That is, we added one more dummy line. So this was the content of the file. Okay, so this is what we did. At least be clear in this. We first had this as the latest, and on top of this, we added one line and we created this commit ID. So that is what we did. So now, if you want to undo this commit ID, practically what it means is, you are going to point the content of the file, that is file.java, back to what you had originally. Because undoing this commit ID means, what was the location or what was the content of your repository before you had created this. That is what you mean by undo, right? So that way, before creating it, we were working on this particular commit ID where we had the content of file.java as one line in it. So in this, we added another line and created this commit ID. So that's what logically we did. So now undoing this commit literally means that you have to go to that situation where in the repository, whatever was the scenario where you never had this content in it, which means simply you have to point it to this particular location. That is the head reference of your file should be pointing to this location where whatever content that you had exactly at this point, you should be having the same thing after undoing this commit. So that is what our practical requirement is. Okay. But as I said, if you try to undo the change, Git will not just directly delete the commit ID because anything that you have put into the repository is permanently tracked. But instead, what Git will do is now on top of this, it will create a new commit ID. And in that commit ID, if you look, this new commit that it is creating will be exactly same as what you have here, whereas it will get the content of the file like this or correspondingly whatever you changed. So this way, this commit ID is exactly equivalent to the content in the files as of this, but in terms of the logical tracking, you have obtained this by undoing some change. So that is how any point of time the reference will be present. So from a user perspective, you're going to create a new commit ID, whereas the contents will be exactly the same as what you had before creating that commit. Okay, so that is how Git is going to track everything, and security wise, that is why it is more popular when compared to other, because in other tools there are scenarios where you can delete the version information, but in this it is not literally possible, whereas the changes can be done on top of the existing. So both the content will be reverted, but it will be creating a new reference for it as a new commit ID. Okay, so let us do the same thing now and see how it is going to work. So now if I say git revert from my workspace, whatever commit ID that you want to give, where whenever you are referring to a commit ID, you can either refer it fully or the short form where the first 7 characters is sufficient to track it. Okay, so with this, if you enter it now, it will be asking us a commit message to enter. That is because internally the revert is going to create a new commit with the reference of the modification. So that is why it is opening a file and asking us to enter what is the message you want to give. By default, this is the message that it puts. As of now, I'm not interested in giving any more messages. So I'll just save it as it is. So now if you look at the content of the file, we have got back exactly what we had before creating this. That is, at this point, whatever we have the content, we got it. And the same thing, if you look at the commit ID, you will not be seeing this, but on top of this, you will be seeing a new commit ID that is going to be the exact reference of this commit. You can see. So it has created a commit because internally from the Git, you have actually modified something, but logically you have reverted the content of a commit from a file. So that is how it undoes a change which you have already committed, but that also will be taking as a new commit ID. Okay, getting it on first, what is revert? So remember, undoing a commit ID in Git literally means that you are actually creating another commit, whereas the content will be pointing exactly to what you had before creating the commit. Okay. Now, coming back to the question that you guys had, where that is correct. Now I have undo the change or I have reverted. And where is this commit ID available? It is available in our change. So literally now, if you are interested to undo a change in your workspace, it is also creating a commit ID. And now anything that is a commit ID in our workspace, if I want to share it to the central repository, then I have to do a push. So that now, if you do a push of this, literally it means that from the content of the central repository, you are undoing the content, and top of that, you are putting a older content, but it is in terms of new commit ID. So that is how in the central repository, you cannot do a undo, because once again, central repository is a bare type repository where you will not be doing any changes. It is only used for storing. So now typically in our central workspace, we would have been having this commit ID, right? On top of that, if we did this and pushed in the central repository also, you would have been this only. Now, since we have reverted it, we will revert in our workspace or wherever you are doing, and from there you will push the new commit ID, so that in the central repository also this will get updated, where the content of this is the revert of this. That means it is going to point to the previous one. So that is how you will be updating the central repository. So anything that we are going to do is going to be a commit ID, and that is what you're going to share it to the central repository, or we will be taking it. So simply, when you want to do a undo, it is not on the central repository. You have to do it in any one of the workspace. So that is when I said either you ask the developer to do, or if you're trying to automate that process also, whatever workspace that you are creating in which we would be trying to do the build or do the testing, right? From that workspace, we will go ahead and undo, and in that you will create a commit, and that commit can be pushed back to the central repository, so that whoever wants to take that as the latest, they will update the workspace. For instance, the developer now he wants to do the change, he will do a pull of that. So in his workspace also, whatever changes that is causing problem will be reverted. In turns, the content of the file will be pointing to the oldest content, and top of that, he'll be doing the changes. Getting it? Do you guys get it on what do you mean by revert, and how do you exactly revert, what happens in the revert, and where do you exactly do the revert? It is not on the central repository. Everything is on your local workspace. Any questions? Others? Vinay, Hari, Karnakar, understanding the concept?
Yes, Adam, I'm following.
Okay, I might repeat the question just to make sure that you guys are following, because if it's a silent, the
Ah,
part that I can think is either you understood or it's completely confusing. Okay, so just let me know as soon
ah,
as that I can proceed.
sure, Adam, sure. I will.
Karnakar? Okay, so now, so we saw how do we undo a change. Okay, that's great. And then we saw from the undo, how is that you are going to create a new commit ID, and how is that you will be pushing it to the central repository. Now, let's take a scenario of the same point for a developer. Okay, now let's say the changes has been creating a problem while you do a build. Now, when you go to the developer, now I will say that, hey, look, I am trying to do the testing, or I'm trying to create a product, and I feel that your change is actually causing the problem, because let's say the build failed or the product creation failed in 5.java. So that is why I'm saying it is causing problem, and we have reverted this change also. And whatever content he has done in 5.java is also not there in the central repository. So that is absolutely fine, because from a product perspective or as a process, you have immediately trying to address the problem by undoing the change, so that You are not fixing, but you are making sure that that problem is not appearing, so that any other latest change you want to put, you can use that and do the testing or create the build. But if you look at the developer's point, in order to fix, how is that he's going to reproduce it? So to reproduce the problem, if he has to once again create the change, it will be a problem, because what we did is simple one line. But in his case, if he has modified more than 10 files, multiple lines, then it is already going to be a headache for him, where he cannot keep rewriting everything. So this is one of the scenario where he might would be interested to go back to a particular commit ID. Okay, now let's say this is your workspace on which you did a pull and you got all the latest one. Okay, now assume that this is what you have got. And now, as a developer, my interest is I want to do the testing of the change, whatever I did, once again, in the same way what the DevOps engineer or the build engineer has done to create the product or testing. So if I want to reproduce, I want to go back to the same content what I had, or simply I want to go back to the same commit ID. So that is how, whenever you have a scenario where you want to traverse between one commit ID onto another older commit ID, then what is that you're going to do? Okay, now simple scenario, as I said, we are currently pointing to this commit ID, right? And now I want to go to this commit ID. Okay, so that is when, if you want to traverse from one commit ID to other commit ID, then you will use the command called checkout, and for this you will give the commit ID. So now what will happen is Git will actually take you from this commit ID to this commit ID, or internally what it means is, whatever the commit ID head reference is pointing, it will take that and it will go back to a older commit ID. Okay, so now here, let's say you have these many commit IDs. Okay, and so currently the head reference is pointing to this one, because this is the latest. By default it points here. Now if I want to go back to this commit ID, then it means that I should tell the Git to get the head reference from there to put it here, so that now whenever the head reference is pointing, it means we are exactly looking at the content in our working directory similar to what you had here. Okay, that is what internally it means. So now what Git is going to do is, if I say check out this commit ID, it is going to move the head reference from here to that particular commit ID, and because of that, the content of this will be visible in our working directory. Okay, so that's how when it moves, corresponding to that you will be seeing only the content. And that is the reason whenever we do a commit, the head reference will keep moving to the latest commit ID, because that is what you are interested to see, and top of that you want to do. In our case, instead of the latest, I am actually going back to an older commit ID. So when you do a git checkout under commit ID, the head reference will move to that particular commit, and in that, whatever content you had, you will be again looking at it. Okay, so let's first do this practically. Now I want to go back to this commit ID. Okay, so watch very carefully. The content of the file is this, but now if I want to go back to this commit ID, let's do a git checkout and this commit ID. Okay, and in this, let's check out the content. So you can see now, this is why Git doesn't delete anything as it is. So any point of time, you can easily go back and refer a particular content that you had. So that is how you can switch. In fact, this was one of the question I believe Vinay or Syed asked me in the very beginning, saying that how is that I can check out only a particular content or only a particular commit ID. This is what exactly you do. So by default in Git, whatever branches you have or the default branch, you will be getting all the copy of your central repository to the local workspace. So in that, in a particular branch, wherever you are working, you will be getting the entire commit IDs as you had in the central workspace. So in that, you can choose where you want to do. So it is not that you will always be pointing to latest. If you are interested to go to a particular location, simply say git checkout to that particular commit ID and it will take you. Okay, so this is the concept. Getting it? On how do you move from one commit ID to the other commit ID?
Adam,
Yes.
hello. Can you hear me? Adam, whenever we do checkout to the particular commit ID, so that means it will be reverting the changes as it was. Am I right?
Don't get confused. It is not a revert. What did I mean here? I said checkout means you are just changing the head reference from one commit ID to other commit ID so that you are looking at it. You are not doing any changes. You are just looking at the content. Now, once again, if you want to go back to this particular commit ID, if you just say git checkout this, then it is just taking the reference of that. Once again, go back to the basics. What do you mean by checkout? If you're going through the very first session in the terminologies of SEM, I said checkout is nothing but the command or the concept where you are telling to the tool to exactly show you the content of what you are interested to work. So that way, if I say git checkout this commit ID, what I'm telling to git is I am interested to see the content, because what it does is it takes the head reference from whatever commit ID it is currently there and it will point it to the particular commit ID where you have told it to check out. That way, that content, whatever you're going to have, will be internally shown in the working directory. So revert is separate, checkout is separate. Checkout means you are interested to jump from one location to other location, but you are not doing anything to the changes. You are just jumping from one commit ID to other commit ID. So if I want, I can once again go back to this. I can come and see the content of this, or I can come. So if you want to traverse between any commit ID, then you will say git checkout and the commit ID, where the head reference will be moved from one location to another location corresponding to what you are seeing. And with respect to that, the contents of that will be visible in your working directory.
Okay, okay, got it. Thank you.
Getting it right?
Yes, Adam, I got it. It's kind of changing a directory. You are going to some directory and seeing the files.
Yeah. Internally, you're not changing the directory, you're changing the content. So I want to go back to older
Yes, yes.
content and coming back to the latest content.
Correct. Okay. It's now it is clear, Adam.
Okay. So if you've understood it, now here, what did I do? I did a git checkout. And suppose if I want to go back to the latest, what is that I have to do? Now, once again, if I say git checkout and a particular commit ID, it will take me to that particular commit ID, so that now whatever the content you have, you're going to see. Correct? This is what is going to do. So if you look very carefully, where did we use the checkout command? Did we use it anywhere else before?
Switching between branches.
Exactly. Now, currently I am using git checkout to move from one commit ID to other commit ID, or traversing between the commit IDs. Okay. Yeah, everything. See, you are not doing any change. You are just going back from one location to other location, and when you come back, so whatever was there at that location, you can easily get it back. So that is what you mean by tracking, right? So what do you mean by exactly tracking? Tracking means any point of time I can go back and have a reference of what you had at that point of time. So that is why we are internally creating a commit ID. So the ultimate point is not about just storing and keeping a record of it, but anytime I want, I can go back to that, and then everything will be there exactly at that location, at whatever you had exactly at that time. So that is what we tell by commit. So if I say this commit ID, whatever that you had at that point of time, you are taking a snapshot and you're storing it as a commit ID. So that means if you go back to this commit ID, you are going to get the exact content what you had as if this was the latest commit ID that you are pointing. Okay, so everything will be shown as what you had at that point of time. So that is what you mean by traversing between a commit ID. So same way, if you have looked, we also use this command to switch between one branch and another branch. That is what, if I wanted to switch between the master branch and the Windows branch, we use this, correct? Now, here, if you look, I am using the same command to specify the branch as well as I am using it to specify the commit ID. So literally, how does checkout work, or Git understand whether this is a commit ID or which is a branch? Okay, so to understand it little more deeper, now the question comes is, where exactly is the commit ID? Okay, so a commit ID is inside a branch. Okay, and where is a branch? A branch is inside a workspace or a repository. So it is like, an example that I can say is, now if you are working in an organization, okay, now from outside, if someone asks you or if they want to identify you, they will say he is an employee of this company. Nageshwar, can everyone hear me? Hello. Okay. All right. So the example what I'm saying is, now if someone wants to refer or identify you, they would say that, hey, this person is working in this organization. But where exactly you are working in that organization, if you come inside, now they will say that he's part of this team, right? That is how they will say that this person within an organization is working in this team. But within the team, if they come and they try to find out, or within the business unit they want to come and find out, then they will be trying to refer exactly with your designation or with your role, correct? So that way you can compare it like this. Okay, so designation, and you can call it as your BU or business unit, and then your company or organization. So that is how anything that you want to refer in Git internally means you have to give all the combination of these three, which means now when you are working, you are ideally going to work on one workspace. Okay, so whatever commands that you're trying to do a commit, push, pull, or anything pretty much is within a repository. So that is how this comes down to this position. But inside our repository, now we know that we are not trying to store directly into a repository, but anything that we are doing a modification is specific to a branch, right? That is how you switch between the branches, and in that branch you specify what you want to do. So now you are going to use a specific branch, and in that branch you are going to do a commit ID. So literally, now if you say that I am working on a Git workspace, ideally it means that you are working on top of a commit ID, correct? So that way, where is the commit ID? You cannot just say that I am directly working on a commit, but that commit belongs to a particular branch, because you will be having more than one branch in your workspace. In that scenario, you have to specify which is the commit ID that you're working, and that commit ID belongs to which particular branch, and this branch belongs to which repository. So that is how you have to say all these things, through which exactly you will be able to point to a particular content. So that way you're going to work in one repository. So that is absolutely fine. So in this, when you're trying to do a checkout, which means you are telling to Git that you are interested to look at a content of one commit ID, then you have to give a combination of both, which means the default way that you have to tell is, you will tell what is the branch and in that branch, what is the commit ID? Okay, so that is how, if you point to something, you have to point in this way. So that is how within your workspace, we will be able to exactly go from one location to other location. So a commit ID is not just a direct commit ID, but it is coupled tightly with the branch. So that is how you have to say that a particular commit ID associated with the branch. Okay, so in the same way, now coming back to the problem, how does it identify both of them? So if you look, if you don't even give the value, then there are certain default value that it is going to assume, because of which we were able to actually go from one branch to other branch. So if you really look, when I did a checkout from one branch to other branch, we were going into the branch, and in that branch everything is a commit ID, right? So on what commit ID are we doing the changes, which means on top of what commit ID are we actually doing? We were working on the latest commit ID only, right? Did we ever go into any other older commit ID and work? No. Whenever we do a git checkout from one branch to the other branch, it was literally taking us to the latest commit ID. So that is how any changes that we did, we were doing on top of the existing latest one. So that way, if you do not give a commit ID, then by default it is going to take the latest commit. Okay, so remember, that is how when we did the checkout of a branch and we didn't tell the commit ID, it means Git will take us to that branch, and in that branch it was taking us to the latest commit ID. That is how we were always pointing at the latest commit ID, and we were seeing the latest commit ID's content, and anything that we did, it was on top of that. Okay. Now, the same thing. In this scenario, sometime back, when I didn't give a branch, but I only gave a commit ID, then it is always going to take the current branch on which you are working as the branch in which the commit ID is available. So if you say git checkout a commit ID, by default it will check on your current branch, and if it is available, it will try to take. If not, you have to tell specifically, or you do a git checkout of that particular branch and then try to do a checkout, or simply it will take it up on the current branch. Okay, so that is how the checkout actually works, because it is not just a commit ID, but whenever internally, if you see, Git understands everything in the concept of a repository, and in that repository which branch, and in that branch what commit ID. So that is how it used to show you the content. Okay, so simply remember this. So far, whatever we worked, it worked in this concept. So now, if you are interested to move from one commit ID to other commit ID, then simply you just pick one particular commit ID, and then if you say git checkout commit ID, it is going to consider your current branch on which you are running the command as the branch in which the commit ID is there, and it will try to go to that, because it will be available in the commit ID. Because if you are trying to search, I am trying to search it from that branch, because this commit ID cannot be the same in other branches unless and until you're merged. But ideally, whatever that you're doing, you are working in that branch, so it will try to switch on that branch. So if I want to move from this commit ID to this commit ID, watch very carefully. There is one more thing that you need to know. So if I move this, currently I'll be coming from this commit ID to this commit ID. Okay, so that is how you move from one commit ID to other commit ID. Now watch this. I was here, now I came back to this particular location, and now if you do a git log, see the output. It is not going to show from here, but it is always going to show from the commit ID where you are working. Can you see the difference? So earlier it was showing everything from the latest to the oldest, but now it is trying to show you only from the middle to the older. That is because git log will always work with the reference of where you are working. So as of now, the commit ID is not pointing here, the commit ID is pointing here. So it takes this as the current commit ID where we are working. So git log means from that commit ID where our head reference is there, it will try to show all the things beneath it. Okay, so it is always going to show the reference based on the head's location where it is. So with the reference of where is your head pointing to, from there it will be showing it. Okay, so understand it. That's how you try to switch. So the point once again now, what is that I have to do if I have to go back to the latest commit ID? Now currently I'm pointing to this, right? If I want to go back to this commit ID, what is that I have to do? You getting my question? Currently from here we checked out and we came to this particular commit ID. Okay, what if I want to go back to this commit ID?
Again, we'll have to do checkout
Exactly.
to commit ID which
Yeah, if I do a checkout and if I give a this commit ID, what will happen? The head reference, whatever that we had, which was pointing at this location, right? So it is pointing at this. So this is where the head reference is pointing. Now, if I say git checkout and this commit ID, this will be removed and the head reference will point back here. Correct? That is how you move from one commit ID to other commit ID based on your interest. Whether it could be an older commit ID or you want to come back to the latest commit ID. Okay, that's a good answer that you said. But now, watch the screen. I did a clear screen. Okay, and now literally I don't know what is that commit ID, because every time if I do a git log, it is always going to show me from my current commit ID only, right? So how is that now I can go back to the older commit ID? Can anyone guess it? The answer is here. What I'm saying is, we came from the latest commit ID to a older commit ID, and now how is that we go back to the latest commit ID?
Then you can do the checkout branch name.
Exactly, sir. So we now know that at any point of time, if I just give a branch name, it will always take to the latest commit ID. Isn't it? That is what I was trying to explain. So now I don't have to worry what exactly is the commit ID. Once again, if I say git check out this Windows branch, literally it means that it will take you to the latest commit ID of that. That is what I was trying to explain some time back, where if you switch from one branch to other branch, it is going to take you to the latest commit ID. But it doesn't mean that to switch a branch, you always have to go to other branch and come. So if I rerun the same command called git checkout and the branch name, it is just going to change the reference of the branch, where now if you look, you are going to point to the latest commit ID. So it will show everything from the top to the older commit ID on that fashion.
Adam, your voice is not audible.
Can you hear me?
Yeah.
So now you can see that whenever you do a git checkout of a branch, now what it has considered is, since you have not told the commit ID, it is going to take the latest commit ID as the default commit ID, and because of that, you're going to get everything back, which means now the head position is moved to the latest commit ID as default, and that is how you will be able to get it back. Okay, so remember these two things. Checkout means it is not just only a branch or a commit, but a combination of the branch and a commit in it. And by default, you are working on one repository. If not, it is actually the repository in which branch and in that which commit ID. But here, since we are already into a repository, so you're going to simply say in that repository which branch you're interested to work, and in that branch what exactly is the commit ID you're interested to work. So that you will tell it here. So if you do not give a commit ID, just give the branch, then it will take always to the latest commit ID of that branch. Same way, if you just tell only the commit ID and not the branch associated to it, then by default it will always take the current branch on which you are working, and there it will try to move the commit ID from wherever you are pointing to that commit ID. Internally, it is not just pointing the commit ID. What exactly it is doing is, it is moving the head reference from one commit ID to other commit ID, and corresponding to that, whatever contents that you had exactly in that commit ID will be appearing in our working directory. Getting it? On what do we mean by exactly a checkout, or how do you traverse between one commit ID to other commit ID and one branch to other branch? Vinay, Karnakar, Hari.
Clear, Adam. Everything is clear.
Okay. So if that's clear, now let's move on a couple of other things which is important. Now let's say, so far what we did, we created a commit, we tried to push and pull, and we were trying to traverse from one place to other place. Now at any point, if you have a scenario where you want to delete a file, okay, now let's say that you have done a release, and after the release that particular file is no more needed, maybe the functionality itself is obsoleted. So you'll be hearing this word a lot in terms of the release management, where you are obsoleting some future. Okay, so that way, now corresponding to that, the files whatever that is going to give you the functionality should not be available in your repository. So that is how when you create a product, based on that, the files will not be there, and according to it, the new feature will also be, that particular feature will also be not available in your product. So deleting now literally means that you are not deleting from the repository, but you should put a reference in such a way that it creates a commit ID, and that commit ID is also available in the central repository. Okay, so when you want to delete a file, simply use the git rm and then delete it. Okay, so let's say I want to delete this file, so make sure to just say git rm and the file name. So what it is going to do is, it is going to do two things. First, it is going to remove from the current working directory, not the workspace but the working directory, and then it is also going to put it into the staging area. So that is how you will try to directly commit it, where it will be stored as a reference. Getting it? So now what it means, you are deleting and you are creating a reference for it. So now if you push this commit ID to the central repository, and from that going forward anyone tries to take that commit ID, on top of that he does the change, he will not be seeing the 7.java going forward. So that is how you delete a file and create a commit ID. And it doesn't mean that you cannot see the content. If you want, any point of time you can go back to a particular commit ID where you had all this content, and from that content you can just refer it. But literally it means, in Git, if you want to delete a file, delete the file and put it into the commit ID or into the repository as a reference through commit ID, and that you push it to other central repository, so that going forward you will not be seeing this file in any of the workspace, because it is not the file, but you are referring to a commit ID in which the directory doesn't have the content of that file, or it doesn't have the file at all. Okay, so that is how it creates a snapshot of that and does the change. Okay, so literally deleting a file means use git rm and create a commit for that also, and use that commit ID as a reference to work. So going forward, on top of that, whatever you changes you do, you will not be able to see that file or files which you have deleted. Okay. Then there's one more thing called as clean. Now, this is again something that we will have to do in terms of testing, where now if I'm trying to do a testing or build of this product, there will be many runtime files that is created. Okay, and in that, if you recall, what is the git ignore? Git ignore is a file in which if we put a file name, then git will not be considering that file at all. Correct? But when you're actually creating a product, it means that you have to do some testing, and for that you will be creating many runtime files. Okay, so you cannot keep adding all these runtime files to a git ignore file and keep tracking it, because at that point of time, if you create thousands of files as a runtime file, it is not easy to keep on adding everything, because that itself is going to take long time rather than trying to test it. So that is how, from a developer point of view, or from a testing, or from a point where you are trying to rebuild the product, if you do not want all these runtime files that you have created, you can just delete it at one shot. Where, what are these files which you have created during runtime? These are not available in the central repository, or sorry, it is not available in your local repository. So that way, what do you call a file which is not available in our repository? We simply call it as an untracked file, because the repository doesn't know anything about it, right? So at any point, if you want to delete the files in your workspace which are untracked, which means which you have created for the first time and the repository doesn't know anything about it, then you will use a command called git clean. Okay, now let me quickly create some files. Let's say I create some Excel file. Okay, and then I'll call it as dummy.log. So that way, whatever files that you create, now all these things will be considered as untracked. And I don't know how many such files will be created, so I don't want to keep on adding in the git ignore and waste my time. But simply now, if I want to delete all these files, then you will use a command called git clean. But before you do a git clean, you can always use an option called -n that will give you the expected files that can be deleted by this action called git clean. So it will clearly show you that these are the files which are not being tracked by the git in your current workspace. So these are the expected ones which the git would remove. Okay, so that's how you do a dry run first. Dry run means don't delete, but tell me what you exactly you're going to delete. Okay, so by this you can cross verify whether you need this file or not. In case if you are requiring this file, go ahead and do the commit of only this. How would you do? Just say git add of that file and it will be added to the staging area. Then do a git commit, only that file will be added to the commit, and then go ahead and do a git clean. So now when you're doing a git clean, use a -f, which represents forcibly clean everything in your workspace which are not being tracked by the git. So now you can see those runtime files or untracked files will not be there and your workspace will be clean. Okay, so clean especially is used whenever on a workspace you have already built a product, or you have already have all the files of the complete product as it which you have used for testing. So now in that case, once again, if you want to create a new product, you don't want all the previous files that is present. So that way you just want to clean everything and redo from the beginning based on the latest changes what you have. So in those scenarios, as a developer or as a QA, or particularly as a build engineer where you have to create the product, you will be trying to do a clean of your workspace which will just delete all the untracked files. Getting it? Is that clear? All right. So let's come to one of the last topic that we have in Git in terms of practical. So tag. So what do you understand or what comes to your mind when I say the word called tag or label? Have you ever come across the word called tag or label anywhere?
Yeah, just it is a reference of wherever we are releasing the code, like just we are based on commit id we can refer it,
Okay, other
like label, right?
Git, other than Git, is there any place where you have seen what is a tag or a label anywhere in your day-to-day
Yes, yes, Adam. In Facebook, every time we will try to add a tag for our friends.
life? That's good. Okay, so now, what is the purpose of tag? You tell me, whatever you said, Facebook, that's exactly correct. So why do you need a tag in Facebook?
So whatever we are doing, we are let them also know, and we are sharing everything with them.
Exactly. Same way, now there is other word that you can use for tag is label, correct? So have you used label anywhere on your day-to-day life?
Label in the sense for it's like a comment. It's like a comment labeling. So if you want any, if you want to give, it's kind of comment only. Label.
Forget about technical. I'm saying you go to a shop, have you seen a label anywhere or a tag anywhere?
Yes, any
Come on.
product you can take, it will some label, right? Some thread kind of thing, they will attach one label.
Yes.
I mean, remembering the how much cost this one.
Yep.
Same thing.
So either it could be a Facebook, which you are creating a tag, or you're going to a shop and you're trying to buy something and you see a label or a tag. So what exactly tag says? So tag, we are trying to attach something as a reference so that if we want to quickly refer something, I can use the tag and quickly refer so that we can easily get the particular reference of it. Okay, so it is the same way now a tag in a Git is used for. What is the necessity? So let's say on a day-to-day basis, we are trying to do so many commit. So ultimately as a user, if you look, what is he doing? He's trying to do a commit. Okay. And like this, there will be many commit IDs that will be done and we are going to store and we create a product test. If everything is fine, we'll move ahead, do a release or keep doing the same thing with commit IDs, testing, giving it to release. So that way, how many releases that we have done, we cannot keep a track directly. And suddenly, if someone comes back and says that, hey, can you tell me what is the release that you have given for a particular customer? I don't know that from what commit ID I picked up because by looking at this commit ID, I cannot easily say that this is the commit ID that I've given. The same way, now, suddenly, if the QA comes back and says that, hey, yesterday I did one testing of a product of a build what you gave, and I think there is some problem and I want to test it again. Can you tell me what is the commit ID that you guys gave me so that I can try to recreate a product and test? Now, not only that, we as a developer or when we are doing some change, we want to know at that particular point of time what is that we did in terms of commit id. So any point of time, if you want to refer something in git, it is a commit id. So it is not easy for us to refer all these commit ids with the names because even though if it is 7 small character, it is not easy to remember, which is complex. So that is when you can create something called as a tag and attach it to the commit ID, where tag is nothing but a string or a name where we will attach it to a commit ID. So whenever we want to refer to a commit ID, if you can remember the name or the tag and you can refer it, internally we are going to point to that commit ID to which it is attached. So that is how it will be easy for us to remember a name rather than remembering a commit ID. So that way, now let's say you are using a tag. Now for what and all purpose you will be using tag? So generally you will be using tag for releases, or to notify or identify a release, or to identify what exactly is the commit ID on a daily basis that we are giving it to a QA for testing, right? So these are the two major scenarios that we can use. But internally, if a developer wants, he can try to create a tag whenever he wants on a particular commit ID. But from an organization, tag is used mainly to identify a commit ID which we have released, or a tag which has been given from the developers to the QA to test. That is the build what you have done, and then what is the commit ID on which you are trying to test. So that way, when you want to create a tag, it is nothing but a name. So every organization will try to follow some kind of naming convention for the tag. So it is completely up to the organization or the product or the person who is trying to take care of Git. They will create a naming convention through which it will be easy for them to understand. Now let's consider that we are also using a tag for applying it for release. Okay, so that way now you can have a naming convention. So now let's say if we are trying to use a tag name for release, I can have something like this. Okay, so I'll say the word as release, which represents that I'm using it for a release tag, and then I will give the version number. Okay, so you can give it like this. For example, I can say release 3.2.1, or I can simply say release 3.1.2, or I can see. So it is just a naming convention that you are going to use. Everything is going to give you the same meaning. It is you, the one who are creating it. So you will be having a naming convention through which it is going to be easy to attach. So now from the commit IDs that you have, okay, so all you have to do is, now you have to pick a particular commit ID on which you want to attach a name which will be as a tag. So that name will be attached to a particular commit ID. So going forward, if you just ask the Git to give you the contents of that particular commit ID, then internally it is going to fetch the details based on the commit ID which is attached to that tag. So that is how it is easy for us to remember this. Now here, let's say we are following this as the convention that in the company. Okay, and now let's say I am trying to attach this particularly to one commit ID. Okay, now let's say I'm using this commit ID, and for this commit ID I'm attaching this naming convention. Okay, so now what is going to happen is you are actually creating a name and attaching it to this commit ID. Okay, by that way, anytime you are referring to this internally, it is going to refer to this commit ID. Okay, so that is what we mean by a tag. Now like this, if I want to create another tag, and I can keep on creating and applying, and we don't have to remember this name, because if you just remember the naming convention, then it will be easy for us to just recall it. For example, if this is the naming convention that I'm going to use, and tomorrow, let's say if there is a older commit ID that you want to refer. Okay, now let's say I am interested to refer a older commit ID that could be like 2.1.2. Let's say you want to refer to that. Then without any problem, you can easily now say that the release tag will be exactly in this format, because this is the naming convention that you're using. So simply refer to this tag name, and whatever that commit ID referring to it, Git will be pointing you to that. So that is how it will be easy for us to refer to a commit ID in the name of tag rather than remembering it. Okay, so how is that you're going to do? So basically, first you're going to use a command called git tag, and for that you will say -a and the pattern or the name that you are trying to put. And for that, what is the message that you are trying to give, so that you will know why is that you are creating a tag, and corresponding to it, to which commit ID you want to apply, you will use it. Okay, so let's try to do that. So now if I say git tag -a release 3.1.2, and this let's say I apply it to this particular commit ID. Okay, and I'll say test commit for release 3.1.2 version. Okay, and then followed by the commit ID. So you have created a tag and attached. How do I see a list of tag? Just say git tag and it will show the details of this. So anytime now, if I refer to this, it is actually going to give you the complete details of the commit ID. So look at this now. If I say git show and this, it is going to fetch the details of the commit ID from which we have created. So it is going to say that this tag is created by this person, this email ID on this date and time, and this is the reason what you have given on the message. And then this is actually pointing to this commit ID, where this commit ID was created by this person and this email ID and the date and time timestamp, and it is going to be giving the details on what exactly you did. So this is exactly as equivalent of saying just git show of this commit ID directly. So whatever that you're seeing it, directly you're going to get it here. So that is how, instead of pointing to a commit ID, you can attach a tag name, which if you follow as a pattern, just keep changing the pattern in the same way with different values. Keep using the same pattern with different values. Then you can always recall any name by just looking at it. Wherein if I say git show, it is going to show me all the, git tag, it will be showing me all the tags that I have. From that, I can pretty much use what commit ID is referring to it. Okay, so that way it is going to be giving you a more meaningful way and an easy way for identifying a commit. Getting it on what do you mean by a tag and why is it you have to create, and practically how do you create? Others, did we get that? So now, to continue this, let's understand one more thing. Okay, now I'll go back to the tag that you guys were saying from a material that you want to buy. Let's say you are trying to buy some product on a shop. So there will be one label on it, where now the same product can be having more than one tag on it. Now let's say that you are going to buy a mobile phone, and in that shop, for that mobile phone, you might have more than one tag, where there would be a tag for price, there would be a tag for the specification details, and there will be a tag which gives you the warranty and other details. Like this, for the same product, you can have more than one tag, which is completely valid. But we cannot have one tag attached to two products, right? Now let's say you're trying to buy an iPhone. Okay, and so in that shop, for that iPhone, he will give you a tag attached which will give the price, and then there will be a a particular specifications of it. Now, next to it, you might be having an iPhone of a different version, an iPhone 5 and an iPhone 4. So now you cannot take a single tag and attach to both. That is because a tag is specifically to that product. So that way, try to remember, one product can have many tags, whereas one tag cannot be shared across product. The same thing applies to the commits, which means one commit ID can have more than one tags on it, whereas one tag cannot be applied to two commit IDs. Understanding it? It is simply because I can do more than one releases on the same commit ID. Let's say I gave the release 3.1.2 on it, and I also gave a release called 3.1.3 on it. But I cannot take the same 3.1.2 and from this particular commit ID, and now if I go and apply on something else, it will not apply because a commit ID will be referring to a tag, and this tag is actually committed internally to this commit ID. So simple logic is one commit ID can have more than one tag, okay, whereas one tag cannot be attached to more than one commit ID. So let's try to see that also. If I want, I can attach the same tag to this also. Okay, now let's say I'll create a new tag and I'll attach it to this commit ID. Okay, now we have two tags pointing to the same commit ID. So this is possible because we have two releases done on top of the same changes. So that is why, oh sorry, is it the same commit ID that I took? Okay, it's just a commit, the tag, right? So now for both of this, I'm trying to point to the same commit ID. Okay, now logically this is fine, but if I try to apply, let's say the same tag for some other one. Now right now I applied to this. What if I try to apply the same tag to some other commit ID? It will not be possible. So let's say I use the same 3.2 for instance, and instead of this I'm trying to apply it once again, and it will say that you already have a tag and you cannot apply. So that is how the concept here is one commit ID can have more than one tags, whereas one tag will always be associated to only one commit ID. Okay, so understand the difference between a tag and a commit ID and how it will be attached. Getting it? Karnakar, Hari. Okay, so understand the difference. How do you tag? Now, you have created a tag. So where is that you have created? Going back to the basics, anything that you create basically is going to be known only to this repository. So ultimately, the tags whatever we have created is in our local workspace. So now, if I want to push that tag to the central repository, we will use git push and give a hyphen tags. So that is when instead of just taking the changes, what the git is going to do is it is going to push the tag information other than the tags. So if I just say git push, it will take only the commit ID. Whereas now, if I want not the commit IDs but the tags, then I will say git push hyphen tag. So by default, git push means commit IDs. And for that, if you are interested only to say the tags, then you will say hyphen tags. Okay. So now we have created it. Simply, if I try to push it, and all the tags will be available in our central repository also. Okay, so that is how going forward, if anyone is creating a workspace, he will also be getting all the reference, so you can easily cross verify them at any point of time. Okay, so you're trying to see that it is trying to push not the commit IDs but specifically these two tags, which is going to be updated in the central repository. Getting it? All right, so let me stop it today. Actually, I just have another 5 to 10 minutes, but it might be confusing. So let me stop, and whatever is there remaining on the Git, I'll explain you tomorrow.